Welcome to today's webinar on SQL Server 2014 in-memory OLTP. This will be the fourth in the series of webinars on SQL Server 2014, and I'll be discussing the in-memory features of SQL 2014. If you have any questions, please put them in the questions bar of the GoToMeetings, and I'll make sure to answer all of them at the end of the presentation. So let's start. The agenda for today's webinar will be covering the technology drivers that led to the in-memory technology and the in-memory OLTP and all the particularities of the architecture and a general overview. We'll cover some use cases and limitations.
The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to the fourth webinar that covers the new features of SQL Server 2014. And today we'll be covering the in-memory OLTP features. And if you have any questions, please put them in the questions tab of GoToMeetings, and I'll make sure to answer them by the end of the presentation. Otherwise, you can contact me by email, and I'll leave another email at the end of the presentation for any further questions. So the agenda for today's meeting is covering the technology drivers that led to the in-memory proposition from Microsoft, and as well for in-memory technology stack. We'll be looking at in-memory OLTP, which had the code name Hekaton in SQL Server. We'll look at the broad overview of the technology. We'll dive into the details of the architecture. We'll look at the use cases and limitations of in-memory OLTP, and then I'll have a brief demo to showcase the in-memory tables and natively compiled procedures. So what are the technology drivers that led to in-memory proposition from Microsoft? The data is growing exponentially, and this has created a new breed of technology. The technologies that can scale up and that can bring the power of cluster computing and unlimited data storage. And when you think about the proposition on the market, everything is filled up with Hadoop, but it's very hard to capitalize on this new technology because you have to have the expertise and all the business requirements that have been already implemented in the current database implementations. They're very hard to transpose into a distributed kind of NoSQL databases. Moreover, the hardware trends, if you look at the hardware trends, the Moore's law has kept up with doubling every 18 months, and we've seen that the number of transistors that we can fit on the CPU is doubling every 18 months, but the clock speeds had actually fallen down because we put more transistors on the CPU. So with the same type of hardware, with the same type of clock speeds, we achieve actually more. And if we look at the prices for these technologies, we see a major decrease in RAM cost, and this has led to development of new technologies for in-memory solutions of storing the data and analyzing data. From Microsoft perspective, the in-memory proposition that builds up the in-memory technology stack comes in three flavors. It's in-memory OLTP, Project Hekaton, that we'll be talking today, the in-memory data warehouse solution, which covers the columnar indexes, which probably you've seen in a previous webinar, and also the SSD buffer pool extension, which covers the hardware specifics of new features of SQL 2014. So why choose the in-memory OLTP? Sorry. The market needs a higher throughput and a predictable lower latency for the OLTP at lower cost. And the market needs the new solutions, the new type of solutions that can be leveraged with the existing expertise. And the combination of these new technologies has to be smoothly adopted in the current existing RDBMSs. And the in-memory proposition from Microsoft, Project Hekaton, gives a high-performance, memory-optimized OLTP engine that is integrated within SQL Server and that is architected to fit the modern hardware trends that are out there. So these new in-memory OLTP, are these just the same type of data structures that we were used to see on the file system that we can that are fed into the memory? No, the actual new data structures, they are optimized for the main memory. So we have a completely redesign of unit of access, the indexes, the concurrency control. And if you think about an existing feature, a previously existing feature, which was the BCC pin table, it's not that, because the BCC pin table was a feature that was bringing the table structures into memory for hot tables that were accessed quite often. But that has been replaced by the buffer pool, and it's already this feature has been deprecated. And this is not an equivalent for the buffer pool as well, because they are based for these base tables. And we'll see in just a moment that the total cost of ownership is kept to a minimum just because of the integration of this new technology. So how did the architecture change of in-memory OLTP? So if we look at the application and the way clients interact with SQL Server, it used to be that all the connections are set to a TDS handler that manages the sessions and connections. Now it has, this TDS handler has a new feature of managing some routing to native compiled store procedures and schemas. And this is all about the Project Hekaton. And now the new features have integrated within the same infrastructure of SQL Server, so you don't have to change anything from the client's perspective, because the clients will still access a SQL Server database, but an underlying thing will be that they will be accessing in-memory optimized tables. So in addition to memory optimized tables, there is a requirement to create a memory optimized table file group, which is a little bit different than to what we used in SQL Server data file groups, because this file group is based on streaming data. So all the data is appended, and in this way you don't have to have a very performant random read-writes specialized drives. You could use a high throughput serialized a sequential read hard drive. And then you ask, how would the interaction between the traditional data file tables would interact with in-memory tables. So for that purpose, SQL Server has a query interop module that translates the T-SQL from the execution plan into commands to the native compiled store procedures, and also the parser and the optimizer knows about the existence of and the particularities of native compiled store procedures and in-memory tables, and this way it adapts to it. So let's just walk through on how this impacts the architecture of the tables. And let's take, for an example, 3 tables that are stored in a data file group. Well, in order to access them, you would have to have these tables in the buffer pool. So let's say we have table T1, T2, and T3 with indexes T1, T2, T2, and T3. As you can see, all of these 6 portions, they have to be maintained in a data file group, and we have a corresponding transaction log for all of them. Now, what happens if we bring these 2 tables, let's say T1 and T2, we recreate them as memory optimized tables? And when I say recreate them, it's because you can't actually alter a table structure, because the in-memory optimized feature works only at create time. You would have to recreate all the tables that you would require to be moved to an in-memory table. Well, in the scenario when we when we created tables T1 and T2 to memory optimized engine, we'll see that there will be a corresponding, for the data files, will be a corresponding T1 and T2 stored in the memory optimized table file group. And then in the transaction log, we will actually have only the data stored, and the indexes will be persisted only in memory. And when we want to interact with these tables, we will have SQL queries, again, running through TDS handler, accessing SQL Server, and the T-SQL will be translated by a query interop into commands in order to access them through natively compiled store procedures and schemas. Okay, now if we want to have a non-durable table, let's say that if we want to keep the table only in memory, what happens then? Then we can mark, let's say, table 2, we can mark it as non-durable, and in this scenario, what happens is the table with its index is stored in memory, and we don't have a corresponding durability in the file group, nor in the transaction log. And this, of course, gives a boost of performance as 40 times. And because it's a V1 product, a lot of the optimization are still ongoing, and the TDS handler is still trying to be optimized to handle different types of connections for the in-memory tables and for the classical disk-based tables. At the same time, for the logging part, it's been optimized for the memory optimized table to be much smaller and reduced, and it doesn't contain any latches, and the persistence of the in-memory tables onto the file group is done asynchronously. So that's why the control is given back to the client while the data is written to the disk in the background. So if you think about all the features or all the pillars that make the in-memory OLTP worthwhile solution, it has its main memory optimized. So that means it's not just a rewriting of SQL Server by means of putting all the page files into memory and having access at page level, but it's rather done at row level and optimized for memories. It's still T-SQL compliance, and it leverages the expertise that you have in your team. It has high concurrency, and it has a built-in multi-version optimistic concurrency control with full ACID support. So what are the suitable scenarios to use SQL Server? Well, you have to think about the name of SQL Server in memory OLTP. The major area would be focusing on OLTP, on transactional data, on committing the transactions as quickly as possible, but it can be used in a data warehouse solution where it's used in the ATL as ETL staging area and so on. But be careful that because it's still version 1 technology, there are still some complexities that need to be resolved by Microsoft in the next releases. So that's why if you intend to implement the in-memory tables, try to focus on a smaller portion of the application and try to be very tactical about this. And Microsoft recommends not to release it for complex surfaces of your application. And the performance gains that in-memory OLTP technology promises are quite considerable. So if everything has been optimized for in-memory access, the web application type of solutions, they should benefit about 25 times. They should have 25 times increase in their productivity. And then just a simple TPC kind of benchmarks, they have a twofold increase in performance. So what are the limitations and considerations for in-memory OLTP? So you have to be aware that memory optimized tables consume memory, and it's not one of those memories that will be released by SQL Server once you run out of available memory on the server and you get more and more data coming through into the tables. So that's why you have to plan accordingly, otherwise disaster is about to happen. There are a lot of documents out there, recommendations on how to compute the memory that will be used by your in-memory tables. So look it up, please, and plan for it. Some other considerations to take into account is that the execution plans for natively compiled store procedures that they are evaluated at the create time. So let's say if you have a portion of the application that you want to migrate to in-memory tables, and that those particular tables are updated quite frequently, you should consider an option of dropping and recreating the store procedure that accesses this in-memory tables. The differential backups, this is one of the overlooked features of SQL Server team, and it hasn't been included in CTP1, and as a result in the CTP2, which was the general available release, they've been implemented as a full backup, so you might expect some surprises over there as well, because the differential backups would take up the quite considerable amount of memory than you would plan for it. And quite an important limitation is that you can't use identical columns on memory optimized tables. So for that you would have to use sequence objects and create store procedures to handle inserts for all the tables. Okay, now let's go for the demo. I'll be showing you what are the steps to follow in order to test the in-memory capabilities of SQL 2014. So here I'll create a database group, and then I'll create a file group that I'll mark it as type fx, and I'll specify where the file is stored. And I can show you at the moment how these data files have been created, so as for a classical database. And after creating the file groups, we'll see how the structure of the folder structure of the data folder has changed. So a new folder appeared here, I'm group mem file group, and here we store all the data files for the in-memory tables are persisted. Okay, so let's create an in-memory table. In order to create an in-memory table, you have to use a simple create statement. You have to make sure that you specify a primary key. You have to be aware that there are two types of primary key indexes that you can apply with in-memory tables. One is hashed and another one is range type of indexes. And more details, we can cover more details later in a later webinar if anyone is interested. So in order to create a memory optimized table, you have to specify at the end of the create statement memory optimized on. This will create a durable table. That means that with data stored on in the file group as well. But if you want to have a purely non-durable in-memory table, you have to specify the memory optimized on durability schema only. So by creating these two tables, we can check what has been created in the background. So if we look at the folder XTP, this is where for the database ID in the database ID folder, we see that there are a bunch of DLLs that have been created that actually correspond with their corresponding C code that correspond to the schema of the in-memory tables. And if you look in the C files, you will see the structures that are quite obfuscated and you can't read them, but they mimic the existing in-memory tables. So how you interact with the in-memory tables? Well, the interaction is exactly identical as to previous T-SQL. You can select the data, insert the data. Everything is identical. If you need to, let's say, use an update, it's absolutely identical with your expertise in SQL prior to 2014. Now let's create a natively compiled store procedure that will actually leverage the ability to insert the data into an in-memory table. So the natively compiled store procedure, they can operate only on in-memory tables, so you have to be aware of that when you want to migrate an existing code base to in-memory tables. So in order to do that, they have the signature is identical to normal store procedures. You just have to specify a few options for native compilation, and also the store procedure has to start with begin atomic. So let me create the store procedure. And once I create a natively compiled store procedure, I can show you in the data folder that a new DLL has been added that actually corresponds to this store procedure, which is natively compiled code. Now, what are the benefits of using natively compiled store procedure? Here, for example, I'll use the store procedure to insert 1 million records, and it should take about 4 seconds. And there we go. Took 4 seconds. And if I take the same code to run through inserting 1 million records through a normal T-SQL, this procedure is going to go for more than half a minute, and I'll just leave it running in the background. So if you have any questions, please put them in the question tab. Okay, so I haven't seen any questions, so I guess that's it. If you have any further questions, please don't hesitate to contact me or the events at imgroup.com. And thank you for listening.